Minasan, konnichiwa. William Rizzo です。ストラテジーリードのMirantis です。よろしくお願いします。Ego is better. Today we're going to talk about standardizing application on multi-cluster topologies for platforms. Again, my name is William Rizzo. I'm a CNCF and Linkerd ambassador. I'm a strategy lead at Mirantis, and I served in the Kubernetes 132 release team. I'm based in the Netherlands.
Unfortunately, I do not speak Japanese. Oh, this is not working. Did you know?
Oh, sorry.
Yeah. There we go. Hi, my name is Erick Bourgeois. I'm the lead platform engineer for RBC, that's Royal Bank of Canada, capital markets area. I'm a huge, evangelist of GitOps. Been doing it since it first came out. Proudly Canadian from Montreal, Quebec. I've been in a highly regulated environment. I've been working in this area for about 23 plus years. I'd really like to thank all of you for coming, and this is the last session, so I know it's the end of the day and it's hard, so thank you very much. And I'd also like to really thank Will for letting me come and join his talk. All right, so as a platform engineer, or as an owner of a platform engineer in a highly regulated environment, I have a lot, there's quite a bit of items that I have to abide by, right? So there's challenges that day in, day out, I have to adhere to strict regulatory standards that are set forth by the SEC. As part of that, while I also have to handle hundreds and sometimes thousands of workloads. So isolating these workloads is another challenge. So being able to isolate them into, obviously the different namespaces and prevent the applications from, communicating between each other. Then there's ensuring the data stays within specific geographic areas, right? So if we have certain applications that are dedicated to Canadian banking, that we have to make sure that data stays within Canada, and similarly for Europe and other regions. All while maintaining audit trails against all of this, right? So we need to be able to go back to our regulatory commissions like the US, the SEC, the US Securities and Commission, and be able to provide those audit trails, right? Then we have these challenges then at scale, right? So, for example, we have, if we have an on-prem data center, and then we have our cloud provider, right? Now I've got about 10,000 developers that I need to be able to serve this up to, and be able to provide that service across multi-regions, and all while trying to keep all of these these challenges in mind. So with the theme of resiliency in this talk we're doing, one of the things we wanted to talk through was looking at how traditional HA and DR, these types of architectures, simple hot-cold or hot-warm scenario, all with maybe even a stretch cluster. Show of hands, how many people have used this or do this on a regular basis? Oh, I'm surprised. Okay. Thought for sure there'd be a lot more, but in these models, if you have a cluster that goes down, for example, there's often, we get a phone call, operations has to be called. There's, a bunch of run books that have to go through, and we have to, make sure that things are up and running, all while, our users are waiting for that to happen, right? That's, tremendously error prone, very costly and inefficient, right?
So, thank you. when we looked into these challenges, of course, we want to address this in a cloud-native way. We have designed some principle in that we addressed in platform engineering on a daily basis, but we wanted to be a little bit more direct about it, more explicit about it. So we addressed the infrastructure topology abstraction, the 3 pillars of infrastructure topology abstraction, as we call them, those principles. So the first one is treating all clusters as a unified pool of resources for the workloads. And this we call, of course, multi-cluster federation. Then we want the platform itself to address failure and rerouting requests and reroute the services and the traffic according to the health of the endpoint that the client is connecting to. Ultimately, we want the Holy Grail. We want to have the abstraction of the infrastructure and the platform for the developers. We want to make sure that the developers are never exposed to the cluster topology, which ultimately they don't really care. What they do need to know is that they're developing against Kubernetes, so that they can optimize their components and their software catalog components that they use for Kubernetes workloads, for Kubernetes infrastructure. Again, what Erick mentioned, the SEC, beside resiliency, has a whole bunch of compliancy that he has to deal with on a daily basis. Unfortunately, I don't have to deal with it. So the compliancy requires security and policy to be uniformly applied to infrastructure and platform, and to be able to audit against those practices. So what we are trying to suggest here is that resiliency should be architected into the platform as a capability of the platform itself, meaning that, again, our developers are ordering service catalog components or data fabric components, and the resiliency is decorated into the service components that are being served for the developers' needs for the business development. So let's go into the actors that we have used for this scenario. So does anyone do not know what's on the slide now? Yeah? Okay. Perfect. So then I go through it. So cluster API. So the cluster API is a series of Kubernetes-style APIs that are used to, I would like to say simplify, but cluster API is everything but simple. So it's used to put behind APIs the creation and lifecycle management of infrastructure and clusters. So we can create managed clusters through these APIs. We have Sveltos. So Sveltos is a controller to manage add-ons and to push policies to manage clusters. And these two things are wrapped around Cordant, a project that we have developed and is open source. Please go on and try it. Is what we call a platform control plane wrapping around, tying together the multi-cluster management and the policy and add-ons management. Anybody knows Linkerd? Oh, I like to see so many hands. So Linkerd service mesh is a service mesh, very lightweight. It's actually the first service mesh ever created. We could have done this with other service meshes. We could have done this with gateway APIs. I see somebody nodding, so you know what I'm talking about. So why we chose Linkerd is because Linkerd, beside being very lightweight and fast, is also particularly simple to implement. The mental model so at 3 a.m., what I care about is that at 3 a.m., if somebody wakes me up because something is not working, I can make a mental model very fastly of how Linkerd works. So I can address the problem and not address the tech. This is the first part. Second, Linkerd multi-cluster topology communication is particularly interesting when we want to have clusters which are addressing only the workloads. We don't want to have a cluster to maintain the control plane of the service mesh. So Linkerd was an obvious choice for these aspects. And then there is how the traffic is handled. Another show of hand. Does anybody know what HTTP route is? Yeah? In context of gateway API, of course. Yeah, oh nice, I love it. So the gateway API, so the HTTP route is an object of gateway API, which is a project of Kubernetes. This object, what it does, it shapes, it defines how and when the traffic needs to be routed. So how is defined? Manually. We define the weights and we define the metrics. So by default, every endpoint has a metric of 1. And we can, and that is a fantastic capability to define how your traffic needs to be managed. What Erick just said is that he has hundreds and thousands of services to manage. Now, what I just said is that you do it manually. You have to define statically your routes for each service that you have with the HTTP route. There is, so in Linkerd, the load balancing of a service is achieved through the UA, which is exponentially weighted measured average. Exponentially weighted moving average. Of course, I missed it. So what, this is an algorithm that is not necessarily used just in load balancing. Is a method to statistically, is a statistic algorithm to observe the data patterns, the data transmission patterns, and balance according to the last average known, to the last data received. So what this translates into is, and I'll get to Linkerd federated services. So what this translates into is if we imagine to have 3 clusters and 3 services defined by in each cluster, so we are load balancing from. If we have HTTP route and we have a definition of 1, let's make it simple, definition of a round robin of 3 clusters and a definition of a metric 1 on each cluster, what happens is that if one cluster is failed, if one service in one cluster is failed, I will have an error 500 that we all hate, a third of the time that I hit that service. The worst thing that I think can happen is that the service is not completely failed, is not really marked as unhealthy from the Kubernetes API, it's still serving, but it's not serving well. So it's slow, and my application or my machinery behind will have problems. So what happens is that a third of the time, the service will not be satisfactory. Now, again, he's talking about scale. Let's imagine this is a one service on 3 clusters. Imagine hundreds of services in hundreds of clusters. So what Linkerd brings into the picture is a concept that they released in November last year, is the federated services. So now what we can do is we can couple together, we can use UA, what I mentioned before, the weighted average, moving average. So the services can be grouped into a federated service. So I can have service from cluster A, B, and C being represented as a federated service. This is really what is going to come up in your kubectl get services. You will have a dash federated. So, and there is this concept of namespace sameness. So if a service has the same name across cluster and is in the same namespace across cluster, is the same service. So we can just create a federated version of that service. We put dash federated, and that's it. We're done. What EOA is going to do when we have a condition, and the client application will hit the federated service, not a load balancing across the clusters. So what's going to happen in this condition is if there is a misbehaving service, UA will be triggering the Linkerd to pull out that service from the federated service and will continue service the application. When the service is marked live again, because the metrics are saying that service is behaving well, it's going to pull back into the federated service again. So, now, in the scenario mentioned by our friend Erick again, in a very large scale, a failure scenario, our developers are still deploying on the platform. They're requesting platform deployments, and this platform is deploying services, mirroring services everywhere, right? Or everywhere we defined. So obviously, those are Kubernetes clusters, but you have to imagine services served by those clusters. Not necessarily each service is serviced across the whole infrastructure, but it might as well be so. So the federated services, just for context, can be routed HTTP, HTTP2, and gRPC. So putting it all together, the way it would look, we would have our developers. So what you see in the square in the middle or in the rectangle in the middle, it's what we call as a platform, right? So our developers or our APIs would be interfacing with the interfaces of the platform, which can be a portal, it can be APIs, and will be requesting provisioning to, in this case, Cordant. Again, Cordant is an implementation detail. We can do all of this with cluster API and Sveltos and a whole lot of YAML that we don't necessarily want to do. And the platform will provision through Cordant the Linkerd version of the services, so the federated service, and it will decorate the catalog components requested by the application, by the developer to satisfy the SEC compliance that Erick is so adamant about. All of this to make our end user happy. That's Erick.
Right, thank you. This slide is definitely a little busy. There's quite a bit here, but these are really the 8 big points that I think we get out of one using CNCF tooling, especially in combination with Linkerd and Cordant, right? So I'm not going to go through every single one. If you want to take a picture and if you want to talk about it through each one, I'd be happy to do that, and I could do it at length. But really, I think the core ones to take away from this are the IAM, right? So being able to centralize the SSO across, especially combining that with some kind of key cloak or any way of doing a unified SSO across the clusters is big. That's a huge deal for my developers, for example. The developers don't want to have to deal with that, right? They don't know it, they shouldn't know it. As a platform engineer, we should be providing those kinds of key features, right? The second part is really the HA and DR, right? So I was talking about those failure scenarios, the traditional way of hot, cold, or warm, hot, warm. This now goes away, right? With Linkerd, you can just be able to run these services right across all of them, and now have a nice, happy set of services that can be accessed from any multi-region, right? So you have your developer in London can access it, or even a trader, for example, who's running down his desktop and be able to access it there, and any failure scenarios are taken care of. And that's it. Thank you.
That was our talk. I have one question before we pass it to your question to you. How many developers are in the room, or classified as developers, at least? And interesting. And how many platform engineers?
Oh, yeah.
There you go. Much interesting.
Yeah.
Okay. Then questions. Yep.
I got a question. How many?
There is one question.
There is a question. Okay.
Thanks for the talk. I have a question. So you basically duplicate the service across the clusters, right?
For me, it's hard to hear you. I don't know if it's...
Oh yeah. Thank you very much for the talk. I have a question. So you basically duplicate the services across the clusters, right?
Mirror, yes.
So what if one goes down? It means it's rerouted to the next cluster?
So that is the concept. We don't want to handle failover. So the platform, the service is being delivered from each cluster at all time.
So.
Yeah. But it means what I'm trying to understand, the latency will get higher, right?
That's what EWA comes in. So EWA is, with HTTP route, that would be a serious problem because each service, we would need to code into how much weight are we going to put in each service according to the latency, according to the resources available in the cluster. With EWA, we are creating, dynamically assigning the traffic according to the metric that is fluctuating, is averaging exponentially changing.
So you're doing it sort of on edge, right?
Sorry?
You're doing it sort of on edge, right?
On edge?
Yeah.
Well, if you think about it with the idea of the traditional HA and DR, often what you would have is multi-region data centers, across the different, like say, let's just take London or Japan, you have 2 different data centers here, right? So you have one cluster hot, another cluster hot, and one fails over, that cluster fails over completely. That latency is quite low because that application now is going over to the other data center within the same city. Yeah.
But I think, I'm sorry.
Yeah, sorry, I'm trying to ask, what if, like, let's say I'm accessing service in UK, and which goes down, and closest one to me somewhere, let's say, for example, in US.
Right.
Latency will be higher, right? So it means the SLO budget will be also higher.
It could be, yes. If the budget of that connection is high, having multi-cluster topology is not going to fix that connection, but it's going to guarantee that you still have the service.
But the key also to this is that I don't think we mentioned was, in the traditional ways you would have this access going to this service, and when that service came down with HTTP route, you keep getting a 500.
Yes.
Or timeout, right?
Yeah.
And then that is actually worse than not, right? That latency. So, yeah.
Does it answer your question?
Yeah. Thank you.
Yes.
Yep. Yeah. So I have a question about immutability. So basically, what is in the manifests equals what is in the clusters. How do you achieve this?
Immutability?
Yeah.
Beautiful question.
Because you were saying like we are using Cordant and Sveltos and other things that are basically generating manifests that then get pushed into the cluster, right?
Okay.
Often in this kind of like banking world, you are required to have a mass of manifests that is then checked into the cluster using some kind of flux, Argo CD, whatever.
Yes.
And then if something changes, you get it rolled back quickly. But here, I kind of don't see it. Where does that happen?
Sveltos manages the add-ons and the configuration. So the way Sveltos works is well, Cordant has also Flux working in it, of course, but we're using only for the Cordant deployment. The management of the clusters is done through Sveltos. Sveltos, the managed objects can sit in Git, can sit in whatever repository you want. Of course, that's audited. That is what is under the auditing, and those are manifest. You have way less. You still need to have a bunch of manifests that needs to be audited, but it's way less than you would use, let's say, with cluster API, just with cluster API. And you audit those components. So those are sitting in Git. Does it make sense?
Or in some
the configuration drift is handled by Sveltos, if that's what you mean by immutability.
Yeah, that's
right. That is.
Okay, thank you.
Yeah.
Hi. I know Istio a lot better than Linkerd, so maybe the question isn't
okay,
quite
next
the same.
Question.
With the EWMA, are you somehow centralizing the weights Or does if I've got 500 pods on each one of those 7 clusters, are they all independently calculating weights and sending random requests across the globe just to keep those weights up to date?
So that's a nice question. So you have 500 pods. Is your service, the federated service, the entity, well, the virtual service, is it one load balancing across 500 pods on 7 clusters in your scenario?
In our scenario, we ideally keep them independent. We don't want cross-communication. But
Right.
if you're saying that we can fail over across clusters, everybody needs to know that other cluster exists. And when that cluster goes down, does every pod independently discover, oh, that cluster is down by sending a lot of wasted requests? Or can you just
No,
know
the pod
Linkerd?
doesn't. So the whole concept of having resilience as a service and having Linkerd doing this, and also with Istio, is that the pod does not know that this is happening. So the cross-cluster service discovery, that's what you are addressing, is done by the service mesh, the control plane of the service mesh.
Discovery, yes, but...
And also the EUA. In this case, also the EUA. It's happening at the control plane.
No, I understand. Sorry, maybe I should have said the sidecar instead of the pod.
Sorry?
I should have said the sidecar instead of the pod.
Yeah.
Is the sidecar the one doing the discovery that the remote instance failed? It can be centralized into the control plane somehow.
Correct. It's into the control plane. The sidecar. So the sidecar with Istio is different. We have Envoy, of course. With Linkerd, the microproxy, the job of the microproxy, that's why it's small and fast, is to hand off this to the control plane. That will do all the job of discovering, all the job that you are load balancing, and this. Did I answer your question?
Yeah, I think so. Istio doesn't report from the pod to the control plane, so everything figures it out itself. If you're reporting back weights, then you don't, everybody can share that information.
Right.
Which is,
but the weight
in this case, a lot more useful.
That's the thing. The weight is not, the weight is not calculated in the serving pod.
Yeah.
Right. Any more questions?
Right there.
Yeah. So you talked about data compliance, right? So for example, have you tried a service where it's a multi-region and the data for a specific region lives only in one cluster? And in that case, if a service fails, how do you handle the UX there?
So I guess that depends if it's on-prem or public cloud. I mean, there's some bunch of different scenarios there. But that also, unfortunately, I can't speak too much in detail. We can speak afterwards, but there's a disclaimer I can only say that a lot of what I do at RBC is, I can't speak too much about. But there are some things that we built internally that do some of this discovery and do the failover or do the determination of where to grab that data. So some of it is built in-house, some of it is using open source CNCF tooling.
I may answer to part of that question without saying specifically in RBC. When there is a compliance constraint like that, some things that you can do is to, with Sveltos, like the gentleman asked, how you guarantee that certain things are in compliance, you can say that this particular workload cannot go beyond these particular regions or these particular failure domains. That's how you would normally achieve this.
Yeah, the idea is to have that high availability within that region zone, right? So that, if that service goes down and that needs that data, it has to stay in there. It has to stay in that multi-region. So there's where the additional, federated service having that across in another cluster in another data center within the same region. That's where it works.
Okay, thank you. Just another question is, for service-to-service communication, do you do federated service to federated service or just internally in the cluster?
Sorry, could you repeat again?
For service-to-service communication,
yeah,
inter-cluster communication, do you from one service, do you call the federated service or just the service inside the cluster?
So you are asking if an application within a cluster needs to call another application within a cluster, do you go through yes, because it would be a client of that federated service, right?
But won't that like cost some extra latency and stuff?
Well, if the federated service is directly, let's say if I have a cluster, let's say we have one cluster, as the service is being served in Tokyo, and another application is in Tokyo, the federated service, it's global, of course. The federated service would connect you over there instead of going, I don't know, to Hong Kong and then Tokyo, right?
Okay. Thank you so much.
Of course. So so we're done then. Okay, thank you very much for the questions.
Thank you.